Hello everyone, a warm welcome to TGIF, your one-stop shop to get the latest in tech. We all are working with large language models and we always have an aspiration that these large language models work very close to our domain, our use case and our data set, and we want them to behave exactly the way we would have in our mind. Today's conversation is to discover yet another topic on fine tuning. And to join me on this short conversation, I have Nandini Muralidharan, Principal Product Manager of Azure AI Foundry. Hi Nandini, warm welcome to DJF.
Thank you so much, Divya. Happy to be here. Hi, everyone.
We posted Nandini earlier in the past. So Nandini, what is the topic for today?
Today's topic is reinforcement fine tuning.
Wow, I think the name itself sounds pretty cool. I remember we had hosted you and you had enlightened us about supervised fine tuning. How different it is from reinforcement fine tuning?
Yeah, let's take a very rudimentary example. In supervised fine tuning, for the training the model, we will have the questions and the answers given to the model, right? And then the model forms its own patterns and learns from it. For reinforcement fine tuning, I just give the questions.
Okay.
We don't give the answers to the model. We rather grade the responses every time the model gives an answer. So you will say, model you have done right, I'll give you 100 marks. Model you have done wrong, I'll give you 0 marks.
Okay.
Based on that, the model learns iteratively
Mhm.
and then gives us the output model. So
Okay.
that's the fundamental difference between supervised fine tuning and reinforcement fine tuning. In terms of use cases, where would you use it? When you know predictably these are the finite set of answers, which is what I would want to train the model with, supervised is the best way of doing it. Okay. But if it is very hard for us to figure out how to arrive at an answer, but you know by looking at the answer, yes, this is the right answer or no, then reinforcement fine tuning is your most preferred technique. So, in practical examples, if I need to threat detection, security risks, or match clauses correctly, I would want to use reinforcement fine tuning than supervised fine tuning purely because there can be n number of ways of solving a problem than just one finite way of solving a problem, like
Okay.
solving a Rubik's cube or a brain data puzzle.
Got it.
Reinforcement fine tuning would do it way better because the model iteratively learn one example after the other.
Got it. Okay, so what are some of the nuances, right? When to use RFT, when not to use RFT, and how to go about it?
So for industry use cases, if I have absolutely decent amount of data set, which is say 5,000 examples and more, then supervised fine tuning in terms of data set size can be a very good method because I have high amount of labeled data.
Got it.
Also, in terms of my task type, my task type is something which has very finite set of answers. It's just classification of yes or no. Supervised fine tuning technique would also be again a very good way of ingest the data or ingest the task learning. Reinforcement fine tuning would do well if I have less amount of label data. Okay. So if I have limited label data, a few hundred samples, RFT can get you started. The second advantage would be, or the use case in which you would take RFT or reinforcement fine tuning, would typically be when you have n number of ways of solving a problem, but a human eye can very quickly say, yes, this is right, this is wrong, but I do not know how to arrive at it, or there might be n number of ways of arriving at a problem. So depending upon your use case, you can use reinforcement fine tuning technique as well. Okay. In terms of costing, so the way we have implemented in Azure, the technique supervised fine tuning is token based. So the number of tokens you consume is how you get paid. For reinforcement fine tuning is based on the hours of training data set, of hours of training the model based on your data set, based on the reasoning capability you are, and hence there is the cost angle also to it when you choose for supervised versus reinforcement.
Wonderful. So can we see how it works?
Let's start with this. This is ai.azure.com, our standard go-to Foundry page. Once we get to that, we have fine-tuning tab here on the left pane, exactly like how we had before. It's the same.
Yeah.
So I go ahead and click on the fine-tuned model. I select the model which I would want, which is say O4 mini in this case, because we are doing the demo for reinforcement fine-tuning. These are the other techniques of fine-tuning which are available, which we did a separate TGIF session the way last time.
Yeah.
So this is the base model which I'm going to fine tune on. The difference between training data set in the way it looks and feels is that the format is different. I do not need a message and response. So you have a different format. It is supporting toll calling and all the advanced things which you would want to support it. Let's go ahead and see how I add it out. So the validation data here is mandatory. It was not mandatory as part of supervised fine tuning. Okay. So I will have it. And then there is the reasoning effort, which is what we spoke about, saying I have low, medium, high. I would recommend people to start with low reasoning effort so that you get an output quickly. You can iterate on it with a smaller example. Okay. And then decide what your production ready use case is. Got it. And then there is the secret sauce, the grader schema and the response format. Grader schema here is mandatory. Okay. Grader schema is typically the same reward model which you would want for your model to know whether it's learning correctly or incorrectly. You can also have a code first experience. This is what we have as part of our build repo page, and Divya would share the details on the post. But we can trigger all the operations which we saw on Foundry using APIs. Okay. And then the data set which we used a sample example of a data where I give you 4 numbers. Model, can you tell me which mathematical operations can I add on to it? Okay. And then give me a right answer. That is what we tried it out. And it gave me a 13% jump over the base model in terms of reinforcement fine tuning. So again, proves a point, limited label data. And we did this with 100 samples of row of data. So limited data sets when you have, and when you have n number of ways of solving a problem, RFT will truly provide the magic sauce which you're looking for in terms of your proprietary use case. This repo and the starter kit is available for anyone to use. So if you just want to get started with your reinforcement fine-tuning journey, there's nothing which should stop you.
So thank you so much, Nandini. Great episode, great demo, and looking forward to host you for many more episodes on TGIF. For all of you out there, please try this out on the Azure AI Foundry platform, and it's very easy to use and get started on this.
Happy fine tuning, everyone.
Bye bye. See you until next time.